Okay, so day 2 notes. We're starting with factoring. First thing you always have to remember with factoring is start by factoring out a GCF. Start by taking out whatever you can from all your terms. From there, you're going to factor based on the number of terms that there are. If there are 2 terms, this is where it's one of the special ones. Either you have 2 squares that you're subtracting, or you have 2 cubes that you're adding or subtracting. 3 terms, this is the one where what I do is split the middle. Some of you, your teachers may have taught you something else, but that's what I do is I split the middle. And 4 terms is you're factoring by grouping. What this means is that you split it down the middle. I will tell you in my experience, this is the one that students tend to forget or tend to not be able to recognize, is when there's 4 terms. 4 terms you approach the same way every single time, put a line down the middle. Easiest way to see this is just to do some examples, and hopefully these examples will bring factoring back fresh into our brain. If we're looking at example 1a, we're going to start with taking out a GCF. First thing you do is you look at all the numbers, -2, -2, and 12. Biggest thing that we can take out is a -2. Then what you're going to do is you're going to look at your variables. I have a to the 4th, a cubed, and a squared. So the question is, what can I take out of all of them? Out of the first one, I can take out 4 a's, but out of the last one, I can only take out 2. So the most that I can take out of every term is an a squared. And then we approach our b's. B to the 3rd, b to the 3rd, b to the 3rd, which means b to the 3rd comes out of everything.
Could we just take out a 2 and not a -2?
Yes, you definitely could. If you want to take out 2 instead of a -2, perfectly fine. Then we have to figure out what's left. Out of this first term, we took out a -2. We took out 2 of the a's, which means 2 of the a's are left. Out of the second term, we took out the -2, we took out the b to the cube. There is 1 a left. This last one, be careful. We took out the a squared, we took out the b cubed. What number are we left with? -6, yes. That's what I want us to be careful with. -6, not +6. Okay, just because we took out the GCF does not mean that we are done. We could be, but we might not be. We need to figure out what's left, does it factor? Okay, so in this one we're asking ourselves, are there 2 numbers that multiply to -6 but add to 1? This number here, this one. It is 3 and -2. Okay, don't do extra work. You do not need to split the middle. If you have a positive 1a squared here, or a positive 1x squared, we can jump right to our factors. Like Drew told us, we get a positive 3 and a -2. Order doesn't matter. And then make sure you bring down that GCF. Theoretically, if we had just an endless amount of free time on us and we wanted to check our answer, how could we do that?
You would have like just foil.
Yeah, exactly. We would multiply it out. I would probably foil this like Drew said, then multiply the GCF in. And we should get back to where we started. I don't expect you to do that because it's kind of a waste of your time, or it's a lot of time. But if you wanted to make sure, you could. Okay, going on to B. Elliot, in B, is there a GCF we can take out?
No.
No, I agree. Elliot, furthermore, if I'm going to factor this, I'm looking for 2 numbers that do what?
Add to 2 and multiply to -24.
Very good. Anybody have those 2 numbers? Charlotte? -4 and 6. Okay, Charlotte, do I need to split the middle here?
No.
No. If you have a 1 out in front, jump right to your factors. So we get x minus 4, x plus 6. Again, order doesn't matter. And we're done. Questions so far? Okay. Anytime you have 2 terms, like you do in C, you have to ask yourself, are these 2 terms squares or are they cubes? Well, 4 is 2 squared, x squared is obviously x squared, and 49 is 7 squared. So these are squares. Okay then. First goes 2x and 2x. Then goes 7 and 7. To get a negative 49, one was positive, one was negative. Question for you. If instead it was 4x squared add 49, does that factor? Kenny? No. Okay, so what we need to remember is if they're squares and if they're adding, it's not going to factor. We're going to go back to D. I want to do E first. For E, 2 terms, again, so we have to ask ourselves, are these squares or are these cubes? Well, 8 is 2 to the third, x is x to the third, and 27 is 3 to the third. So these are cubes. This one is going to be a little bit different. What I'm going to show you might be different than what your teacher did last semester or last year. Here's what I do. I want to emphasize this only works if it's a cube. Okay. 8x cubed is 2x times 2x times 2x. 27 is 3 times 3 times 3. Anytime you have a cube, you're going to have 2 sets of parentheses. First set of parentheses, you take one of each. So we have a 2x and we have a 3. Second set of parentheses, you are looking at the pairs of numbers. And you're going to multiply. So 2x and 2x gives us 4x squared. 2x times 3 gives us a 6x. And 3 times 3 gives us a 9. What we have to do then is fill in the signs. The way to remember the signs, the acronym is SOAP. S stands for same. So negative here means I have a negative here. O stands for opposite. So opposite of negative is positive. And AP stands for always positive. This quadratic, or this second set of parentheses, will never factor again. So at this point, we're done. If instead it was 8x cubed add 27, does that factor? So if it's cubes and we're adding them, does it factor? Amina? Yes. This factors. We're going to look at D, but I have a few quick notes for us before we look at D. So if you could write these down, please. Let's say that you have x to the 4th minus 16. Some students will approach this one similar to what they did in E. And they'll go, okay, x, 2, 2, 2, 2. You cannot do that. What we did in E only works when there are 3 terms. If there are 2, 4, 5, anything other than 3, that doesn't work. So x to the 4th minus 16, how would we approach that instead? If we can't write out x 4 times and 2 4 times. Charlotte?
It would be x squared minus 4, and then x squared plus 4, and then you would leave x squared plus 4, and then it would be x minus 2, x plus 2.
Yes, these are perfect squares. Thank you. These are perfect squares. And then like Charlotte said, this one would factor again. So that's the first note I have for you. Second note I have for you. I want you to write down all 4 of these examples, and all I want you to do is tell me, does it factor? That's it. Does this factor, yes or no? x squared minus 1, x squared plus 1, x cubed minus 1, x cubed plus 1. Take 30 seconds. All I want is does it factor, yes or no? Let's see. Liam, x squared minus 1, does it factor? Yeah, it definitely does. First one's a yes. Okay. Audrey, second one, x squared plus 1, does it factor?
No.
No, it does not. Thank you. Owen, third one, x cubed minus 1, does it factor? Yes, it definitely does. Thank you, Owen. Last one, Zoe, x cubed plus 1, does it factor, yes or no?
Yes.
Yes, it does. Only one we need to worry about, like Audrey told us, is if we are adding squares. Adding squares doesn't factor. Anything else is all good. Questions on those before we do our last factoring one, and then we take a break. Okay. Last one is D. I left D off for us because it's a split the middle one, or I left it until the end. Anytime there's a number in front of the x squared and we have 3 terms, things are a little bit different. This is the one where you're going to multiply the first number and the last number, which gives us 72. We are looking for 2 numbers that multiply to 72, but add to the number in the middle, negative 22. Anybody know what those are?
Negative 18 and negative 4. Or negative.
That wasn't the numbers I came up with. Yeah, you're right. There we go. 18 and 4. Negative 18, negative 4. Okay. A lot of students can come up with those numbers. But then here's where they go wrong. They say, okay, I have x minus 18, x minus 4. How do we know that that is incorrect?
Because that doesn't equal the top one.
Yeah, Drew already told us like 10 minutes ago to check our answer, we multiply out. If we start boiling this out, we're going to get x squared, not 3x squared. So this is the one that takes extra work. That's not what we're going to do. Instead, we take this middle term and we rewrite it as that negative 18x and negative 4x. Order doesn't matter. Bring down the first term. Bring down the last term. And then like we said before, anytime there's 4 terms, put a line down the middle. So we're going to take out GCFs on both sides. Kira, what is the GCF on the left side?
3x.
3x, and then in parentheses, we'll be left with x plus 6. Kira, since you're on a roll, what is the GCF of the right side?
Negative 4.
Negative 4, it is. Be careful with signs here. Ah, I made a mistake. Where did I make a mistake?
Left side.
Left side, I definitely did. Charlotte, what is my mistake on the left side?
It should be negative instead of positive.
It definitely should be. Thank you. Benedict, how do I know I'm on the right track? Phone a friend. Nikolai, how do we know we're on the right track?
When the parentheses are both the same.
Parentheses need to be the same. So they are. One factor is x minus 6. Other factor is what outside 3x minus 4. And there we go. Does this seem familiar? Yeah, from a lot of us it is. Any questions for me? Okay, now that we've factored, we're going to continue with quadratics. This time we are solving quadratics. There are 2 things you have to be able to do. Sometimes I will tell you solve using this method, and you have to be able to use a specific method. Other times I will just say solve, and you have to choose what's best for you. We are going to start by solving using particular methods. I want to tell you my order of preference. Here's what I do. If I'm given a problem and I'm told just solve, the very first thing I try to do is the square root method. So that's what we're going to start with. Square root method. You can have an x squared, but you can't have an x. You can have an x squared, but you can't have an x. In our case, we kind of have an x squared. Question is, can we get that squared part alone? And we can. So that's what we're going to do. I'm going to move the 18 over. don't FOIL this out. You certainly can, and you'll get the right answer, but like that's just a lot of extra work, so don't do that. Again, I'm trying to get the squared part alone. Okay, that was step 1, get the squared part alone. Now what? How can we get rid of the squared?
Square.
Square root. Nick, what do I have to remember when I take a square root?
Plus or minus.
Very good, thank you. Plus or minus. Nick, while you're at it, what's the square root of -9?
I or 3i.
Very good, 3i. Lastly, move that 4 over. So we get -4 plus or minus 3i. Technically, this should have brackets around it. If you don't write them, that's fine. Okay, that's the first one. Now, if something doesn't factor, or if something you can't, if we can't use the square root method, next thing I always try is factoring. This problem here, why are we not allowed to use the square root method?
Because there's an x alone.
Because of the x. So because of the x, we can't use the square root method. So we're going to factor. What are we going to need to do?
Multiply -12 and 6 and add 1.
Okay. Has to multiply to -72, but add to 1. I'm going to give you 1 minute. Get as far as you can with factoring this, please. That wasn't a ton of time, but the two numbers we were looking for were 9 and -8. Then we got to split the middle because of that 6. Put a line down the middle. Left side, I can take out a 3x, and I'm left with 2x plus 3. Right side, I can take out a -4, and I'm left with 2x plus 3. Benedict, how do I know I'm on the right track?
The same.
Yeah, same stuff in parentheses. Thank you. So we get 3x minus 4 and 2x plus 3. How do we know we need to keep going?
Is it an equal 0?
There's an equal 0. Remember, we are solving. We're not just factoring, we're solving. So both of those get set equal to 0. 3x minus 4 equals 0. 2x plus 3 equals 0. Which gives us two answers of 4/3 and -3/2. Again, technically your answers should be in brackets. Diana, hopefully you remember this, a little bit of a throwback. How did we know from the very beginning we were going to get two answers? I know, I put you on the spot.
It's equal to 0?
Not quite, but thank you, I appreciate it.
Because it's their term is squared. So
Okay.
you need to-
X squared tells us we're going to get two answers. So make sure you do, in fact, get those two answers. Okay. Questions before we look at the next two? Okay, so if we can't use the square root method or we can't factor, my very last one that I try is the quadratic formula. Quadratic formula is always going to work. Carly, why can we not use the square root method on this problem? It's not the x squared, it's a different term though, that's an issue. The x, yeah. Anytime it has that x, can't use the square root method. Alexia, if we were going to try to factor this, we'd be looking for two numbers that did what? Close. Multiply to -4. Multiply to -4, add to -4. There are no two such numbers. So we can't use the square root method. We can't factor. We're going to have to do quadratic formula. This is our A. This is our B. This is our C. Quadratic formula is the opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. So in our case, that gives us 4 plus or minus the square root of -4 squared. That -4 is in parentheses. Minus 4AC all over 2A. Okay, inside of the square root is where students often make the mistake. So please be careful there. Okay, so that negative 4 squared gives us positive 16. Be careful of the sign. Negative and a negative will give us a positive. And again, we have 16 all over 8. Ooh, I think I'm going to run out of room. Hopefully not. This gives us 4 plus or minus the square root of 32 all over 8. Allie, at this point, can I just divide everything by 4?
No, you have to do the square root of 32.
Okay, we got to simplify the square root first. Don't just divide by 4. Simplify that square root of 32. Like we did yesterday, 32 is 8 times 4. 8 is 4 times 2. I'm not even going to keep going because I already have a pair of numbers. 4 goes outside the root. 2 that doesn't have a partner goes underneath the root. So this gives us 4 plus or minus 4 root 2 over 8. And then lastly, when we're simplifying, a lot of times your teachers have shown you that heart, divide everything by the same number. In this case, everything is divisible by 4, which gives us 1 plus or minus 1 root 2 over 2. This 1 is necessary. So when we divide this 4 by 4, it gives us a 1. That 1 is necessary. David, how many answers is that?
2.
It is 2. How did we know from the beginning that we were going to have 2? Square on the x. Okay. Last one, completing the square. Here's what I want you to know about completing the square. You are only going to use this when you're asked to. When you're specifically told to complete the square, complete the square. Otherwise, the other 3 are normally better methods. What I do want to point out is in order to complete the square, we have to have a 1x squared. So this problem for quadratic formula, we couldn't complete the square here because there's a 4 in front. You have to have a 1x squared. Okay, so here's what you're going to do. The number gets moved to the other side. So we have an x squared plus 8x. Completing the square is the one where you add a number so that you can factor the left side. Way you find that number, you take your b term, you divide it by 2, and you square it. So 8 divided by 2 is 4. 4 squared is 16. So I'm going to add 16 to both sides. Right side, we get a 21. Left side, Amina, if I go to factor that, I'm looking for 2 numbers that do what? Left side. So when I go to factor this, I need 2 numbers that do what? Multiply to 16, add to 8. Maria, what are those 2 numbers? Multiply to 16, add to 8. 4 times 4, always going to be the same number. So this can be written as x plus 4 squared. So we have x plus 4 and x plus 4. At this point, we can take a square root. Like Nick told us, I don't know, 20 minutes ago, when you take a square root, don't forget, not 20 minutes ago, 10 minutes ago, don't forget the plus or minus. So our answer ends up being negative 4 plus or minus root 21. Part of your homework is going to be like that, where it's going to say specifically use this method. Questions on any of those methods before we just have a free-for-all with use any method that you feel like. You do need to know all 4. Okay, I'm going to do 2 problems with you, and then you are going to do 2 of them. Anytime it says solve using any method, first one that you're going to ask yourself, can I use the square root? Then you're going to ask yourself, can I factor? Then, if you can't do any of that, you're going to use the quadratic formula. Okay, so let's give this a try. Jamie, can I use the square root method on the first problem? Is there an x squared we can get alone?
Yes.
There's an x cubed, not an x squared. So that's a no. Okay, no square root method. So we're going to move on. Audrey, can I factor the example in A? What's the first thing you always look for when you factor? Is there a GCF here?
Yeah.
There definitely is. GCF in this case, 2x. And we're left with x squared minus 4. Okay. Audrey, does this factor again?
Yeah.
It does. What does x squared minus 4 factor to be?
X plus 2 and x minus 2.
X plus 2 and x minus 2. Okay, so set all three equal to 0. 2x equals 0. X plus 2 equals 0. X minus 2 equals 0. Which gives us 0, negative 2, positive 2. Kenny, how did I know from the beginning I would get 3 answers?
It's
X to the third, gonna give us 3 answers. Okay, we're gonna do D, and then I'm gonna leave you all to do B and C. Looking at D. Rachel, can I use the square root method?
Yes.
No.
Quadratic.
Yeah, you're like really skipping ahead. Can't use the square root method. Kira, why can't I use the square root method?
There's another x.
There's another x. Amina, if I go to factor it, I'm looking for 2 numbers that do what? Multiply to 7, add to negative 4. There are no 2 such numbers. So, Rachel, like you said, we can do quadratic formula. Rachel, if I wanted to, could I complete the square here? I didn't tell you to, but could I if I wanted to? Yes, how do you know?
Because there's 1x squared.
1x squared, so I could complete the square. Rachel, I'm going to leave it up to you. What do you want to do? Quadratic formula or completing the square? Completing the square, let's do it. Okay. That 7 gets moved to the other side. Carly, how do I figure out what goes in that space?
Divide negative 4 by 2 and square.
Take negative 4, divide it by 2, and square it, which gives us a positive 4. So we get a negative 3 on the right side of the equation. Brett, what do I get on the left side of the equation when I go to factor it?
X minus 2 squared.
Very good. Yes, I do. X minus 2 squared. So then I'm going to take a square root, which gives me x minus 2 equals plus or minus. Nikolai, how would I simplify the square root of negative 3?
just be I root 3.
It would. Thank you. Which gives me finally 2 plus or minus I root 3. Questions before you all try the last 2? Here are the 2 answers. The first one is 1/3 and negative 5. So that's for B. For C, you should have gotten plus or minus 5i over 3. In B, you cannot use the square root method because of the 14x. I chose to factor. If you want to use the quadratic formula, that's fine as well. You should have gotten the same answer. In something like 3, where I say solve using any method, I don't care what you do. So if you want to use quadratic formula for every single problem, that's fine. But on your quiz, there will also be problems that say solve using this method. So you do need to know the different methods. Here, make sure you get plus or minus. I have 2 comments on your work, so I want you to look up here. A lot of times, you get the right answer, but there are 2 things that a lot of us do. On an example that's factoring, a lot of us go from this line to the answer without fully showing the factored form. You have to show this line. This is the factoring. Don't jump from here to an answer. I want that line. The other thing that I see a lot of you do is you have equal 0 in the first line, but then you don't write it ever again. You need to make sure that every line is an equation, that it has equal 0, that you have equal signs here, that you have equal signs here. Don't just throw it in at the end. For the most part, it looked like you all really knew what you were doing. How do we feel about this? Okay?